Hello, once again, this is Sim Racing Tech. This is getting a little bit late, but I want to do this video today, and I want to deliver on something I promised on my Facebook page, on the Sim Racing Tech Facebook page a little while ago, some couple of weeks. I want to show you how to calculate the perfect camber angles of cars in ISI-based simulations, and I want to do this by using a little bit of trigonometry and the ride height of the vehicle. So quickly, what we need to do is to make some maths. Dog, keep quiet please. I'm recording. And I want to calculate the difference in height between the left and right, because that gives me the distance of one of the sides in this triangle. That makes out, if you have a triangle, short one on one side, you have the bottom of the car, which is the width, and you then have the third side going across, and always at the bottom, over here on the triangle, you have a straight 90-degree angle, and you can then use trigonometry to calculate the angle over here, right? Perhaps a little drawing would have been in favor here, but this is not really the point. The point is to calculate the angle. How it's done, yeah, sure, it doesn't really matter. I'm going to explain this quickly now. So first I need to calculate the amount, or the height difference. So I do this, I want always a positive value here. So I take the absolute value of ride height in one side minus ride height in the other. I build my little math for this, call it body roll front, since I'm calculating in the front. Okay, to that I do the same again, this time for the rear of the car. Sorry, it's not the right one. This is the right one. Absolute value, ride height left minus ride height right in the rear of the car, gives me the body roll in millimeters of the car. I could also do like I've done prior to this, which was to calculate the body roll on average. But no matter. Forget that for now and just use the front and back, because it's interesting how much the chassis of the car actually twists while going through corners. So let's see how we calculate this. We take a sine to the body roll front, which was the absolute value of the difference ride height in the front, divide that by the vehicle track width, times 2 pi. Now this is in millimeters, and apparently for some reason this formula needs to be in centimeters, so this will give you a result that's 10 times too small to what the actual angle is, and you can then multiply this by 10 and you will get the correct value. So put all this in for both front, and use the body roll rear to do the same calculations. Press OK, open up some meaningful data to you, and obviously you want to optimize the camber angles for corners on the track. So this time I've been practicing the Le Mans track for the GTR 24H, and I'm setting up a GT car. So I want to look at the camber angles right here in the tire file. This could be a TBC file from R-Factor that has exactly the same values. So what I'm looking for here is the camber lat long values. So this is the peak camber angle. This is the camber angle at which the tire generates the most amount of grip, and I want the tire to be at 2 degrees of camber when I'm going through this corner. Now the car is already tilting by 1.4 degree, so you can calculate what camber angle should I be hitting to make this to make it result in this total camber angle on the tire. Since the whole car plus the tire is already tilting by 1.5 degrees, how much do I need to add to achieve 2 degrees of camber on the tire in relation to the road? Now, I'm not going to give away the obvious here, but you can figure this one out. I'm going to leave this one for you to figure out. And just a little piece of keep this in mind, or give this attention. The camber angle is not the same for front and rear tires. The optimum camber angle is not the same. This is of course obvious because the tires are not the same width. If they were the same width, it would obviously be much closer to the same camber angle. It's not. I suspect this camber angle is there to simulate the warping or movement of the tire on the rim when you go through the corner. So to give or simulate that the tire needs to achieve when it's pushed inside onto the rim on the outside wheel going through the corner, it is to simulate that you need a bit of camber to make the tire patch contact the road as optimal as possible. So to simulate this, there is an artificial high optimal camber angle on these tires that is not 0 degrees in relation to the road. But you need to achieve this going through the corners, and now I've shown you how to make the calculations to calculate the roll of the body and thereby the static angle of the tire without any camber. So this is the camber angle at 0 degrees, and you need to achieve 2 degrees on front, 1.5 degree on rear. How much camber do you need to put in the car to achieve this? Calculate it safe. Well, this has been Sim Racing Tech for this time concerning camber angles. I hope this was useful to you. See you next time. Bye bye.